Welcome back to the Hyperbolic Coding Chamber. We have returned once again to battle not against LeetCode LLC or the developers or the content creators, but mostly against ourselves. So we had some amazing discussion in Discord today, just seeing how people talk and exchange different ways to accomplish stuff and good resources. Shout out to Ring Ring and everyone else who's sharing some resources and whatnot. Also, I think I had a lot planned for this week, and it turns out I think we're taking a different route. I think I'd planned to stream this week amongst other things, and I think and in doing some retrospective, maybe that's redundant. Doing some retrospection. I feel like a animal who has to keep relearning the same lessons over and over again. And I think I'm realizing now, if I want to get what I want out of my existence, that future and the way I live my life currently are mutually exclusive. That is to say, I don't think it's possible for me to both yearn for and aim for and eventually, feel like I'm getting to where I want to be at the same time and also live the way that I currently do. And that's really strange because this feels like something I relearn over and over again. Maybe that is part of the journey, relearning the same things over and over again. Maybe there's a theme here, but yeah, it's just been an interesting thing to think about. Because I thought I was going to do a lot this week, but at the same time, there are patterns in the way that I live my life currently that are just incompatible with the future that I'm hoping for. So that just goes to say, I realize now, when I'm asked usually why I'm doing this, I always say I'm using LeetCode as a vehicle to train focus. But that is true, but in the day-to-day, there's a process of forgetting. And I guess in the book I'm reading currently now, they talk about part of there's like a chronic forgetting, right? In a moment, you're empowered or your emotions are mobilized by some properties of your environment. You decide to make a change. The future is inspired by this change, and then as you move forward, as those changes begin to take effect, right? Then you start to think, why was I making this change originally? And then you fall back into your old ways. And I think this is similar to how this journey has been. I decided to try to do things differently. We're not doing anything crazy. We're just doing LeetCode every day. But even that has proven to be quite the formidable challenge. And there's so many more things I want to do. But it's just been interesting to see how much this thing was so much more about me battling myself than it was about LeetCode or anything like that. And it's just very interesting. So thinking that way, I'm realizing now I had planned to do a lot of things, but I don't think I think there's a way I can probably do them at the same time. At the same time that I'm saying all this, I always think it probably seems strange that my thoughts bounce around so much, mostly because in a way the beginning of these videos is pretty much like a journal entry. So a lot of the thoughts are non-linear, or they riff off others, or I'm just saying what's going on week to week, and I feel like it looks strange. But I think it's just I'm just kind of saying what's on my mind and thinking through the process. So I try different stuff week to week. I try different stuff day to day, just trying to figure out how to make stuff work. All this to say, I don't have all the answers, but I do realize I guess the thing I want to stay with, I don't think the way I'm doing things now is going, I think the way that I'm doing things now in the future that I want are mutually exclusive. And I think part of the reason I'm getting some of the results that I'm been able to enjoy recently, like being able to get as far as we've gotten, because we haven't gotten that far in the LeetCode. But to me, they always say to compare the best competitor. Best competitor is your past self, or the best competitor is your future self, or something like that. But compared to my previous self, I think, it's very satisfying thing to like reconcile. So all this to say, there needs to be some change, and I think part of the reason we've made some results so far is because some of the things have changed. But at the same time, I think I'm realizing the limits of this change, if that makes sense. In fact, it feels, oh my god, I have perfect analogy. It feels a lot like One Piece spoilers coming up ahead. It feels a lot, well, it's not spoilers, this is like episode 500 to 600, and there's about 1100 episodes out right now. But it feels a lot like Luffy in the beginning of the show. He has gear 1, gear 2, you know, maybe a median version of gear 2.5. Eventually, he's able to get pretty far with these gears, and you know, he beats a couple bosses, but each time, right, the first time he goes gear second or first or whatever, he fries the boss. The second time he does it, he's still frying, but not as hard. Later on in the show, once you get out to episode 500, I mean, he's jumping to gear 3 like every battle, and it's still a bloodbath basically. And I think that's where we're at now. The solution then was for him to go into the hyperbolic time chamber and grind it out, and then the whole process restarts again. But I think what I'm realizing now, there are a certain amount of changes that I made that have worked very well, which has allowed me to make daily progress on this LeetCode thing, even though we still have a long way to go. But I think I thought how much time I was spending LeetCode would be a function of how much time I would spend on LeetCode, right? If I put more time into LeetCode because it was a vehicle to train focus, it would branch out to other areas of my life, which it has. But I'm realizing now, I think there's only so far. This only goes so far. So I can do about an hour, 2 hours of LeetCode a day, but I can't do much else. And I thought that was a function of how much focus I had achieved, which is relatively sort of true. But I'm realizing now there's a cap on that. I can't really do much outside of that. So when I was doing the game dev thing, it was a little bit tough to do both at the same time. Additionally, with all the other things I was doing beforehand, if we rewind back like 3 months ago, I think we were doing like an hour and a half of LeetCode, and I was doing 30 minutes of system design and 30 minutes of ADM, and then 30 minutes of Rails practice, and then 30 minutes of front-end practice. It was like a 3-hour stretch, but this is ultimately unsustainable. And I thought it was unsustainable because how much I could focus was capped. I'm realizing maybe I'm modulating focus in the wrong way. I think what might give me more capacity for focus is changing other things. So I think that's the wave. And yeah, so that's what I'm gonna try. I'm talking very general because, you know, I don't want to spill my whole beans out here, but yeah, I think I'm gonna try some different things. Nothing's changing or anything like that, but I mean different things in like trying to modulate different things in my life to see if those things help or don't help with increasing capacity. Because one works for 8 hours and you have to do all this extra stuff. And I think we kind of got the LeetCode thing down. I think the changes I made so far have been able to get me to get this thing working. So I'd like to get more time out of that day. And I think that is the next project. So got to figure out how to do that. So that being the case, it probably means we're going to go back into the reading bag. And I'm already there because I'm reading a bunch of different books. Well, I try to read only one book at a time, and then finish and go on to the next one. Hopefully we'll find more information so that we can make more changes. Not too much, of course. Hopefully to move in the right direction. So that is where we're at. But fortunately, we have a legendary comment from a legendary computer toucher and a legendary human, as well as a visionary thinker. And also, Bakugo X Midoriya type vibe. My thing isn't coming up. Give me a second. So yeah, so we have a comment from the legendary Control-C Anbu Ninja himself. Your future self will thank you. Facts. So if the comment, I think I said before, yeah, we got to get on our discipline bag. And we got to get in our discipline bag. And yeah, we just got to find ways to get there. There is, I think the features are just mutually exclusive. So I think there's just, I can't, TLDR, I don't think abusing dopamine, I think abusing dopamine and getting everything that I want in the future are mutually exclusive, is the TLDR. It took me 10 minutes to figure that out. That's what I was trying to say, but I don't think it's possible to abuse dopamine and also get what I'm looking for. And I think part of the reason I was able to even do this hour LeetCode thing, even though I think other people have been able to achieve far more, but it's because I had made some changes to not abuse dopamine in other ways, and it has worked. So I think it's just a necessary evil. So that being said, we're signing up for the casual suffering required to continue the process of transformation. Unfortunately, we have no shortage of problems because LeetCode developers have a propensity to inflict suffering upon us. So it's an arms race, and I think they release about, I think we did the math earlier, it's like they release problems in batches, but it roughly averages out to about 1 problem a day or something like that, or like 0.8 problems a day. But either way, we're making good progress through the easies, and I think we're definitely no longer being as challenged by the problems. So maybe we can wrap all these up and then hurry up and get on to the mediums, because I'm itching for some challenge, and I think we definitely were able to get a ton out of these problems. So hopefully, at the end of the day, hopefully we're just testing whether or not it does make sense that doing all the easies and doing all the mediums and doing all the hard, given infinite time, is the best solution. So that being the case, make sure to join the High Hyperbolic Coding channel because the HCC needs you. We just had a member in our Discord expose all of the top 10 tips to get into the top 25 secret programming organizations. We also have tons of secret cheat codes as well as resources pinned in the Discord, courtesy of some of our awesome members. So great time to be alive. Also a great time to do more problems. So also a great time to push ourselves. So I think we're going to jump into it, and we're going to do the standard hour as per usual. And yeah. So let me check if my screen is still updating. I think it is. I think we did this problem yesterday. Oh, we didn't. Okay. So we'll do this one, then we'll continue. Also, I started drinking this thing called Hint, and I'm going to take the hint and stop buying it because it's not good. So that being the case, I'm gonna jump into it. Check if one string swap can make strings equal. You're given two strings S1 and S2 of equal length. A string swap is an operation where you choose two indices in a string, not necessarily different, and swap two indices in a string, not necessarily different, and swap the characters at these indices. Return true if it is possible to make both strings equal by performing at most one string swap on exactly one of the strings. So we have bank in con B, and if we swap one of the characters in con B, if we swap K and B in S2, we get bank, which is true. And then there's no way we can swap any of the characters in either of these to make them the same. I was gonna say you could check the structural property of the strings. For example, that both strings have the same number of letters and occurrences for those characters, for those letters, but then that would probably break the ordering problem. For example, we could have Kelby and Belk, and our algorithm would return true there, even though it shouldn't. So that's not the solution. We could either run with that and then add. Nah, but that still wouldn't work either. The minimum requirement, though, at least, is that s1.length equals s2.length. So if they don't equal the same length, we can definitively return false. maybe we could try and, so what we did here is we pretty much iterated through both strings and we checked if they had at minimum 2 characters that were incorrect. This worked for most of the test cases, except for test cases where we had something like AA and AC where the character lengths were the same and they did only have 1 difference. Maybe the truth is you have to have at least 2 wrong characters. I said less than or equal to 2. This could be exactly why we're having some problems here. Because if we make sure that there's at least 2 things that we can swap, then this case would become true. I guess the other thing we should also have to check is if S1 equals S2, return true. If you got further, this still isn't good enough. So you have A not matching C and Z not matching A. Oh my god, I just realized, yeah, how do we forget that dimension? You need the letters the letters that we're swapping to actually match. So we see that we must have at least 2 characters that are incorrect, and for those 2 incorrect indices, they must match the. I see. Well, we're checking here that if S1 does not equal S2, so there's a little bit of complicated Boolean logic that I think we're gonna need to write. A, C. So basically, what I'm trying to say is, if we know that there are 2 incorrect characters, right? We don't know if it's C, right, and A that are matching A and Z, or A and Z that are matching C and A. So we have to check for both. Maybe we don't actually. If we presume that both of the strings are if both of the strings are actually correct. What do we have before? Like con B, I think. Right, you can swap B and K. If the strings are actually true, right, we know that B doesn't equal K and K doesn't equal B. But if there's only 2 mistakes, 2 strings that are incorrect, it basically means that B must equal B must equal the second index, right, and K must equal the first index. There's only two potential positions it could be in, since we're only allowing 2 mistakes. So in this case, we would have in both strings that both indexes 0, right, and 3 do not match in this string, right? 0 equal B, right, and 3 equals K. So we could say, since 0 doesn't equal 1 in the other one, but index 0 in S1 must equal index 3 in S2, and index 3 in string 1 should be equal to index 1 in string 2. That would ensure that both of the characters that are missing actually match. What we were originally doing was kind of like a structural check, but didn't make sure that the letters that were missing actually mattered. So we can do like this. We can say missing index, right, which would just be an array, a tuple of number, right, and we'll expand this. We'll place ct plus equal 1 in here, and since the strings are of the same length, presumably after line 2, we can safely say that missing index dot push I. I'm not exactly sure why missing index is. Let me just click run to see why it's giving me an underline here. Oh, did we add a test case by mistake? Oh, so we do know that they have the same length, so we can actually remove this case. And then we'll also remove case 4. And then it should tell us why our underline is giving us trouble. And we're gonna say and S1 SubMissing. So we want to make sure, right, is that B, like the first index equals the first index of the first string matches the other index of the second string, and so on. By checking S1 to S2, we should be reflexively checking S2 to S1 as well, I think. So let's just see. Sub1. It might just be easier to say const. And then we just have to say S1 to missing index 1 should match S2 subindex 0. And then we remove the extra ampersand, add a semicolon. I feel kind of off. I don't feel like this is gonna work. Oh. I wonder if we ever had to check more than this, though, it would be really difficult. There's also an issue with the method I went about solving this. I didn't know that it didn't work until running it multiple times. Maybe that's okay. I know in contests you can't keep running code. So I think I should have thought of a solution ahead of time to make, or thought of this a little deeper, so as to make it make sense. But I think I didn't think of the test case AA and AC. That being the case, I'm pretty sure this runs in linear time with constant space. Actually, now that I'm realizing it, I think there is a special algorithm you can write. I don't remember what it's called. Is it Diffie-Hellman? I think it's Diffie-Hellman. And you can use a matrix to represent, there's some like 3-dimensional matrix, and dimensionality represents how many characters are different or something like that. I think I'm also realizing this problem is also represented, I think, in a medium. It had something to do with graphs, but I'm not exactly certain. So we have another problem. Minimum sum of 4-digit number after splitting digits. You are given a positive integer num consisting of exactly 4 digits. Split num into 2 new integers, new1 and new2, by using the digits found in num. Leading zeros are allowed in new1 and new2. Interesting. And all the digits found in num must be used. For example, given num 2932, you have the following digits: 2 2s, 1 9, and 1 3. Some of the possible pairs are 22 and 93, 2392, 2239, 2329. Determine the minimum possible sum of new1 and new2. Interesting. I wonder if the maximum, oh no, it says it's always a 4-digit number. If it's always the 4-digit number, it seems possible that we could just use like a combinatorics approach. Maybe there's an easier way. So what I'm thinking is there's 4 numbers, and since there's only 4 numbers, there's only I think, yeah, there's 4 numbers, so I think there's only 4 factorial ways that they could be summed up. So you'd have 2 9, you'd have them individually 2, right? And whatever is left is what you would add on to it. So you have 2, 9, 3, 2. Well, you can only have groups of 2. So whatever isn't used is the remaining number. So you'd have 2, 9. Yeah, and in fact, I think it would actually just be 3. No, it would be. Would it be 4 factorial or 3 factorial? I think it would be 3. Because you'd have 2, 9, 3, 2, 9, 2, 2, 9, 3, 2, 9, 2, 2, 3, 2, 2, 2. Maybe there's so I'll think about 2 ways. Combinatorics, or if is it permutations? I don't really know the difference. And then we'll try maybe another version. Let's try simple Intuit cheat code. Maybe there's a simple solution that we can employ that will give us the ideal answer. We want the minimum sum that 4 numbers. Minimum sum of 4-digit numbers after splitting the digits. So since it's always 4 numbers and you can split it in 2. Is there a hard and fast rule that always gives us the smallest sum? We have 2, 9, 3. For example, what if we sorted the numbers? We have 2, 2, 3, 9. But that actually doesn't give you the smallest amount. It's 2, 9, and 2, 3 that gives you the smallest amount. Maybe there's a simpler thing you can do where you can take the smallest number and pair it with the largest number and continue to do that. I mean, pair the smallest number with the largest number. So if we had something like 2, right? If we had 2, 9, 3, 2, you would take 2, pair it with 9, then you'd take 3 and pair it with 2. That's all you can do. If you had 4009, you would take 4. Zeros throw a wrench in it. Oh wait, no you wouldn't. No, it doesn't. You would take the smallest number, which is 0, and pair it with the largest number, which is 9. Then you take the smallest number again, which is 0, and pair it with the largest number again, which is 4. That would give you 13. If you had all zeros, it wouldn't change. If you had all the same number, it wouldn't change. So at the end of the day, I'm thinking if we turn this the number to a string, and then we turn, or pretty much spread. I guess we could do it also this way. You could just spread the number into a string and then map each number, which is a string now, which is an array of strings, into a number, which we'll call nums. From here, we'll sort nums. We could also done this with a heap, but do nums.sort, and we'll sort it from ascending to descending. From here, you can say that minimum sum is going to be equal to while nums.length is not equal to 0. I'm going to say minimum minimum sum plus equal nums well, it's a number and we'd like to combine them, so we can combine them into a string like so. We'll do num sub 0, right? And then nums sub nums dot length minus 1. And then we'll wrap this whole thing in a parse int. And then what we'll do is we'll say nums we'll remove the first element and then remove an element at the end, which would be the first element would be the smallest and the last element would be the largest. And I think this should give us the minimum sum, at least for these two test cases. But I can't imagine how it wouldn't give us the sum otherwise. What if we had 0, 1, 0, 0? We'd get 0, 1 plus 0, 0, which would be 1. If we had 7, 0, 7, 0, we'd take 0 with 7, 0 with 7, and get 14. Nice. So this works. Maybe there's a, you probably don't have to sort this because it's always 4 numbers. Either way, since the string is always 4 digits long, I would say this is constant time. And constant space as well. Is there a follow-up? Ah, that's clever to subtract from 0. So, looks like we had the same intuition. The solution was a little bit different. I mean, the way people saw that was different. So we have given an m by n matrix, given an m by n matrix of distinct numbers. Return all lucky numbers in the matrix in any order. If all the numbers are distinct and we have a matrix. Lucky number is an element of the matrix such that it is the minimum element in its row and the maximum in its column. I'm thinking we could do this in m by n time, where we would pre-compute another matrix which would have the minimum elements for every row as well as the maximum elements for every column. And then we could just iterate through all the numbers in the array, checking which ones are lucky, and then we could return that array. So we could say for row and call, and then we'll use this data to compute. So what's the best way to store the data? I mean, even if we look at a starting one, then we could just have two arrays for rows and columns, and you could pass in the row or column where you're in to get the value. That makes the most sense to me. So min for row 0 would give you the minimum for the row for the 0th row, and so on. So min for row is going to be an array. Wondering if there's a way to do it we'll change all the rows and then this to matrix of row dot length. This is a little confusing because we're going to calculate the min for the row in the column block and the min for the row in the row block, if I'm following correctly. So for this one, we get, oh no, well, for column we'd go, oh no, we'd probably have to do the same loop. To get all the rows, we'd start column row sub 0, boom, 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 reset min, push it onto min for a row, and then we'd have to do another loop to calculate max for column. Where you'd be going through the rows, or you'd be going through the columns. The way you would iterate through the columns since it's a rectangular array, we could iterate through the matrix sub 0 dot length, and then through matrix dot length calculate that. We'll say min we can copy this whole block. This time we'll swap it for column because we're going to want to iterate through every column. starting at the 0th column. The column we're going to stop at is matrix sub 0 dot length. This is just because the array is rectangular. We can use that first value. We'll change max to negative infinity and row and call to row. And then every row has the same like height, which is the matrix dot length. And then we'll take the max of max and matrix sub column sub row. So we have a column, we want to iterate through all the rows for that column. And then we should just have to do one more it's called max for column. I'm going to return an empty array, but we should just have to do one more loop to find the lucky numbers. Right, the column is staying the same and the row is changing. So the max for the min for the 0th row is 3. We should get 3, 9, and 15. So we get the max for all the columns should be 15, 16, and 17. And that is exactly what we get. So I think we can do one more regular iteration through, and here we'll create a new array called const lucky, which is just going to be an array of numbers, and instead of this empty array we're going to return lucky. So we have a number, right? We have its row and its column that it's in. So if matrix of row, might be easier to just say const num is equal to matrix of row sub call, which would be the current number that we're on. If the number that we currently have and then we have the number, we just have to check it's the min for its row, right? And it's the max for its column. So if we take the min for a row sub row equals num, and max for a column sub column equals num, we'll say lucky, and we can return it in any order. This one's a bit of a grind. So this would be n by n time, because we're doing it 3 times basically. And I don't know if would we I guess n by n. No, actually we would use, I guess, n plus m space, or n would be the number of rows. M would be the number of columns. We use these arrays. So for n columns, you would have n max numbers for those columns. So 2 sum less than k. This sounds like it's going to be the worst. So given an array nums, so you have an array nums of integers. So you have an array of integers and integer. So you have an array of numbers and an integer k. Return the maximum sum such that there exists I is less than j. Given an array nums of integers and integer k, return the maximum sum. Return the maximum sum such that there exists I is less than exists I, which is less than j, with num sub I plus num sub j equaling sum So we're pretty much given an array of numbers and a value, right, which is technically just an upper bound. An upper exclusionary bound. So we just define 2 numbers such that I is less than j and I plus j. Oh, we want to return the maximum, yeah. Pretty much we're given an upper bound, we want to return the maximum sum that is closest to that bound. If no I or j exists satisfying this equation, return -1. Looks like the numbers were given max out at 100 and k is maxed out at 2k. It's the best way to go about this. I think 2 sum is usually looking for a particular sum given 2 numbers. I mean a particular sum with an arbitrary amount of numbers. Here we're just looking for a number which is less than k. That is gotten by adding 2 numbers together. We could brute force this with n squared time. N squared time to generate all the numbers, right, that you can add together. And then we could just keep the number with the smallest difference from k. can k equal 0? It can't. I'm thinking. You can brute force it, keep number with the smallest non-zero difference from k. Since I has to be less than j, it'll be slightly less than n squared. So instead of saying j equals 0, we'll say j equals I plus 1, since I has to be less than j. And we'll just say sum is equal to num sub I plus nums sub j. Then we'll say answers equal to 0. Additionally, we'll say that min difference from k equals infinity. This is how I know when to update the value. And then we can say diff is equal to k math.abs of pretty much k minus min difference from k. Actually, might be better to say min difference from k minus k. This will give us the difference, the number, or the range, the distance it is from k. We'll want to keep the number with the smallest distance that is also less than k. So if sum is less than k and diff is less than min difference from k, we'll say that answer is equal to sum min difference from k is equal to diff. And let's just check that. Let's just say, right, we use 34, right, and 23. The sum is 57, right? We'll do min difference from k, which is infinity minus 57. This actually gives us an issue because I'm pretty sure in JavaScript, if we do something like infinity minus a number, you just get infinity. So I'm going to check real quick. If we do infinity minus 20, I'm pretty sure you still get infinity in JavaScript. Alright, you still get infinity, which means that the answers that we start with, are we guaranteed at minimum that nums will have at least multiple elements? It does not, we're not. So other thing we're going to say, if nums.length is not equal to, we're going to return -1. And then we can set our answer equaling nums sub 0 plus nums sub 1. Additionally, min difference from k starting at infinity was giving us an issue. So we'll start it at math.absolute value of k, let's just say it's 35 or something, minus 54, which would be answer. I think this should give us the correct, maybe not. This code also doesn't address the possibility that we possibly won't find the number. That's why infinity worked well. I feel like we can solve this, but I feel like my brain is tired. Answer is equal to num sub 0 plus num sub 1, which is 30. The difference from k here would be 15 minus 30, which would give you 15. It's a difference. Issue is, this can't be the answer because we don't know if it's less than k. If we started everything back at 0 again, the difference of 0 is too good. If I do difference from k minus k, if I say k, min difference from k I'm sensing that the answer here is literally hidden in just following the code through, but I'm feeling very resistant to that. So given an array of nums, right? So basically if we start the answer at 0 and min difference from k equal to 0, doesn't really work because the difference we find would never be less than 0. Or we could add a little fix here to say, or min difference from k equals 0 to get us out of there. Then when we get to 57, we can say, oh, min difference from k is equal to 0. So we'll just update min difference from k to be 1. Oh, which would give us 3. Because 60 minus 57 would give us 3. Similarly, when we get to 58, we'll say 58 is less than 60, and 58, or the diff here, which is 2, is less than the min difference from k, which was 3. And then if min difference from k, if we never have a number that sums up to be less than k, min difference from k should be equal to 0. So at the end we can say if min difference from k equals 0, we'll return -1, otherwise we'll return answer. Oh, I think I see what's happening. It might just be that we're not actually. So we go from all the way to the end. We get all the way to the end, right? With 34 and 24, we do 24, right? We never access 34 because I is equal to this number and j is equal to I plus 1. We want to consider both pairs no matter which order they come from. This version only allows 34 to be added to 24 if... No, wait. Something's wrong here. Because now I'm actually not seeing how we're not getting the correct answer. 24 does indeed come after 34. Writing 34 and 24 to get 58. Yeah, I'm not even getting anything at all. Something. Oh man, this is supposed to be if nums.length is less than 2, return -1. And it shouldn't be min difference from k minus k. It should be k minus sum. That's the difference. You can delete this console.log. Yeah, I'm kind of embarrassed that one took as long as it did, but Yeah, sometimes I feel like there's a math of it where you have to look through and observe how each line of code is running. And sometimes I just don't want to do that. This would take n squared time, or a little less than that. I see how they're doing the binary search. If you sort the array and then do a binary search for the number you're looking for, no, actually no, that doesn't make any sense. You still have to do n squared time to generate all those sums. Nah, I think you definitely could. If you sorted all the numbers, I think a two-pointer approach could work. But I don't know for certain. But I think tomorrow we'll start with reading the solution, and I think they have a linear time solution. They have an n log n solution, n log n, and an n plus m. So that's pretty cool.